So hello everyone, let us solve another LeetCode problem, and the problem name is maximum square area by removing fences from a field. So there is a large m-1 cross n-1 rectangular field with corners at 1, 1 and m, n containing some horizontal and vertical fences in areas h fences and v fences respectively. Now horizontal fences are from coordinates h fences of I, 1 to h fences of I, n. So for example, there is one horizontal fence. So let's say h fences of I is given to be as h fences of I is, let's say, 3. So this will be going from 3, 1 to 3, n, because this is how a horizontal fence is. So at the third row from the first column till the end column. So this is how a horizontal fence is created. And similarly vertical fences are from coordinates 1, fences of I to m, fences of I. So let's say v fences is given as let's say one of the example, v fences of I is given as 2. So it will be going from 1, 2. So this is one fence. So this is 1, 2, and it will be going from m, 2. So this is how a vertical fence is created, from the first coordinate till the end coordinate at the second column. And similarly, this is how horizontal fence is created, from first coordinate till the end coordinate at the third row. So this is what they are saying about the fences. Now they are saying that return the maximum area of square field by removing some fences or possibly none, or return -1 if it is impossible to make a square field. And since the answer can be very large, so return mod 19 plus 7. And then they have given some note that you cannot remove the boundary fences, because if there is a field which is m cross n, or whatever they have given, n cross m or whatever, if there are some horizontal and vertical fences, so this boundary you cannot remove, this boundary. So this is what this note is saying. The field is surrounded by two horizontal fences at coordinates 1, 1 to 1, n and m, 1 to m, n, and two vertical fences from the coordinates 1, 1 to m, 1 and 1, n to m, n. These fences cannot be removed. So you cannot remove these boundary fences. That is what they are saying. So how we can solve this problem? Let us understand with the help of one simple example. So let us take this example. So how a square is formed? A square is formed by taking two horizontal fences and two vertical fences which are at the same distance. So let's say this has some width, this has some width, same width, and this has some height, and this also has some height. Now this height and width should be equal. That is when we can say that okay, a square is formed and we can calculate its area. So what we are doing, we are choosing four sides of the square: the first top one, the bottom one, and the sides one, the two side one. So what we can do in the brute force manner, what we can do, we can select all four sides. So we can run a for loop for selecting top side, then we can run a for loop for selecting the bottommost this one, and we can run a for loop again to select this side, and then we can again select a for loop for selecting this side. And if the condition matches that all of the sides are equal, we can calculate the area, and we can keep a max area and just update the max area with this particular area if this current area is greater than the max area. So we can do this kind of thing, but this will give us TLE. So we cannot do that because the constraints are very large. So we cannot run four for loops, but we can still run two for loops because constraints are also not that much large that we cannot run two for loops. So we can afford to run two for loops. So what can be the optimized approach? So instead of selecting all four sides at once, we need to select the four sides optimally. So what we can do, we can first select what all possible horizontal sides we can choose. So let's say this is the grid that I have. So I have just drawn the grid. So in this, what we can say, how many possible horizontal sides we can choose. So in this, let's say these are the horizontal sides. So one possibility is that we can select these two horizontal sides. One possibility is that we can select these two horizontal sides. One possibility is that we can select these two horizontal sides. Another possibility is that we can select these two horizontal sides, another possibility that these two horizontal sides, and another possibility that these two horizontal sides. So we can select all of these horizontal sides, and for each of the horizontal sides we can select what height we are getting. So what all possible height we are getting. So whatever possible heights we are getting, we can just store it in some unordered set. Let's say possible heights. Let's say this possible height contains some, let's say whatever, for now just take some random values. So these all possible height it contains. So we can create an unordered set. Why unordered set? Because here we don't need to do anything with the order of the elements. So we don't need anything like ascending or descending order. We are just keeping an unordered set so that we can check in future whether this particular height exists or not, because we can create a square if and only if width is equal to height. So we are just keeping a set for a checking purpose. So for checking purpose we can create an unordered set of possible heights. Now these are the possible heights. So we found what all possible heights can be there. Now how can we make a square? If let's say possible heights are these, so we will also have some possible width, right? The thing which we are doing for getting the height, we are selecting all combinations of selecting horizontal sides. So same we can do with the vertical ones as well, right? We can select all possible ways of selecting the vertical lines as well. So what we can do, we can create a possible width as well, which will contain some value, let's say 5, 7, 8, 9. So these will be the differences which will give us the width. With the possible widths we will be getting the width. Now we can compare whether this 5 exists in the possible height or not. Yes, 5 exists. That means we have the height of 5 and we have the width of 5. So we can create a square and we can get the area 5 cross 5. Similarly, if we have some other value present or not, yes, 7 is also present. So we can create a height of 7 and we can create a width of 7. So it will create a square of 7 cross 7. Similarly, if we have some other value or not, yes, we have 8. So we can say that okay, we have a possible height of 8 and we have the possible width of 8. So we can create a square of side 8 cross 8. So we can calculate the area 5 cross 5, 7 cross 7 and 8 cross 8, and among that whatever gives you the maximum, obviously this 8 cross 8 will give us the maximum. So we can return the area as 8 cross 8. So this is what we'll be doing. Now we'll not be creating the possible width array because there is no need to create. So while like calculating the possible widths, we can just directly compare it with the possible heights, whether currently we have the possible height with this value or not. So there is no need to create even the possible width unordered set also, because we can do this thing in single pass only. So what I am saying that as we have chosen this possible heights, we will be choosing the vertical lines as well to get the possible width. So how we can do, we can select these two as the two vertical lines, we can select these two as vertical lines, we can select these two as vertical lines. Similarly, we can select these two as vertical lines, we can select these two as vertical lines, and we can select these two as vertical lines. So we can have what you can say some possible width also. So these are the possible widths that we can have. These are the possible widths. So what you can do, the possible heights we have calculated by taking the difference and all that. Now similarly we will be calculating the possible widths. So we will calculate, okay, what was the previous vertical line we have choose and what is the current vertical line we have choose. So with the difference of that we will get the width. Now we will directly check whether this width is present in this possible heights or not. If it is present, we will just calculate the area and check if this current area is greater than the current maximum area or not. If it is greater, we will update our max area with this. So you see, we don't need to create a possible width unordered set, because we can just directly compare it with possible heights in the current run only. So this is how we'll be doing. So first of all, what we are doing, let me just summarize it. So let me just summarize. So here is this summary of what all things we are doing. So first of all, we are calculating all the possible heights and storing it in unordered set. And storing it in unordered set. How we are calculating the possible heights? By taking the difference of current and the previous bars that we have. So difference between current and previous bars we choose. This is how we'll be getting the possible heights, and then we'll be storing in the unordered set. Now same thing we'll be doing for the possible width, but we will not store it in unordered set. So what we can do, same, calculate all the possible width, calculate all. So this was the first point, this is the second point. So calculate all possible width as well. Now how will you calculate all possible width? Same, taking the difference between current and previous bar we choose. Now we don't need to store this particular thing in possible width unordered set. We can check whether this particular width exists in possible height or not. So whether this width exists in possible height or not. If yes, that means we can create a square of side width cross height which is same height and width. So if yes, we can create a square of side width cross width or height cross height, because both of the value are same, and calculate the area. And then basically just compare the current area with the maximum area and update the maximum area if the current area is greater than the current maximum area. So this is what we'll be doing in this particular problem. So I hope you understand. So let us see the code now. So this is the code. So first of all, we are pushing all the like the side border coordinates or the boundary coordinates also in the H and V respectively, because the height or width which we are taking, we can also take it with the boundary ones as well. So that's why we are first pushing all the boundary coordinates in the H and V respectively, and then we are sorting. Why we are sorting? Because we need to check whether this current bar that we have, what is the difference with the previous bar. So we can only compare if they are sorted in ascending order. So that's why we are choosing we are sorting H in ascending order and V also in ascending order. After that, we are creating an unordered set of possible heights of what all possible heights we can have, and then we are initializing our answer with -1, and then we are running 2 for loops to get what all possible heights we can get by selecting any 2 bars at a time. So we can have any 2 bars to choose at a time, and what height can we get by choosing those 2 bars we are calculating here. So whatever the current bar we choose and the previous bar we choose, the difference will give us the height. So we are just inserting this difference in the possible heights unordered set. Same thing we are doing for the width also, but instead of storing the width, we can directly compare if this width is already present in our possible heights or not. If this width is present in a possible height, that means we can create a square with side width cross width or height cross height, and we can calculate the area. So we'll be calculating the area with width cross width, and if this current area is greater than the maximum area that you have so far, so we'll just update our answer with this current area. And in the end, we are just checking if the answer is -1, that means we cannot create any square, so we are returning -1. Otherwise, whatever answer we have, we are returning answer with modding it with mod value, which is nothing but 1e9 plus 7, and in the end we are returning the answer with this modded value. So this is how we'll be solving this problem. So I hope you understand this problem. Thank you for watching.